Hi everybody, we are going to do 12.2 arithmetic sequences first. I am going to make some adjustments to the calendar. So I'm going to take out 12.1. Just, we're basically pretty much out of time at this point. So I'm going to take out 12.1, which is fine because it's just generic sequences. But we're going to still do 12.2 and 12.3, which is more specifically 12.2 is arithmetic and 12.3 is geometric. So we'll do those two. I already decided before to knock out 12.4, and then we'll just do 12.5. So we're only doing the 3 sections from chapter 12. And here's what I decided to do about that, because I don't want to take the test away, because a lot of you may do well on the chapter 12 test. Like, people do tend to do well on it. So what I'm going to do is, because I think it's a lot to have to do a classwork, a quiz, and a test. So I think I'm going to take the actual doing of the test away. And instead of actually doing the test, your quiz is going to count as your test. So your quiz grade will count twice. It'll count for your quiz grade and it'll count for your test grade. And then your test grade can still potentially be replaced by the final exam grade if it's higher. Remember, your lowest test grade gets replaced by the final exam, and the final exam still will be this day. I'm looking into using the honor lock system, which we're supposed to use to give our final exams. I have a training on it on Thursday, so after Thursday I'll know more about that. But like I said, this chapter 12 test is now your quiz grade. Your quiz grade will just count twice. And I have to go in. My plan is to do it tonight. If not tonight, I'll do it on Wednesday. My plan is to go in, and I do need to fix your quiz to take out 12.1. 12.4 honestly was never in it. But I do need to take out 12.1. And you didn't ever have a 12.4 homework assignment. So that's the other thing, is your 12.1 homework will go away as well. So your homework grade will just be based on the 3 sections. So this should simplify it down, make it more doable to do within a week. And I like the classwork because I think it gets you a little bit motivated to maybe get started on the content instead of leaving it up to last minute. I know we're all just kind of trying to do what we can to get everything done and all that. So, okay. So let's get started with 12.2, which is arithmetic sequences. There's 2 different kinds of definitions that you could give to define a sequence. There's the recursive definition, which we're going to do first. And then there's nth term definition. Okay, with your recursive definition, you start with a sub 1 is the first term. That's your A. And then your next term, A sub n, is based off the term before, which we'll just call A sub n minus 1. The sub numbers just define what they are, like where they are in sequence. And then you're going to add on however it's changing to get from one to the next. Now D is its own separate thing. D is the common difference. In arithmetic, you have a common difference, a number that's being added or subtracted to get from one number to the next. Geometric, we're going to multiply. But for here in 12.2, and anytime you see arithmetic, we're going to be adding or subtracting. Alright, so let's look at number 10. And some of the notations are a little bit different from what you may have seen in the past. Number 10, you're given this. You're given the set of b sub n's is equal to the set of 3n plus 1. Now, I personally don't know that I ever saw this notation before I worked out this book, but it's just another way of writing the same thing. It says, show that the sequence is arithmetic, find the common difference, and write out the first 4 terms. Okay, I think all those kind of go together. So I'm going to start by writing out the first 4 terms. So b sub 1 means that our n is 1. So it'd be 3 times 1 plus 1, or 3 plus 1, which is 4. B sub 2 would be 3 times 2 plus 1. 6 plus 1 is 7. The third term in the sequence would be 3 times 3. We're just all these are replacing the n. Plus 1, so 9 plus 1 is 10. You also might see what's going on here. Each of these is increasing by 10, by 3. So you add 3. So I know this answer is going to be 13 without even doing it. But we'll go back and do it. B sub 4 would be 3 times 4, which is 12, plus 1. It does, in fact, give me 13. So the first 3 terms of the sequence, the arithmetic sequence, are 4, 7, 10, and 13. That answers one of the questions. It also asked, it says find the common difference and write out the first 4 terms. So our common difference is how we get from one to the next. So to get from one to the next, we're going to add 3. So our common difference is 3. That answers the questions there. All right, now the nth term of the arithmetic sequence. Okay, so to do this, there is a formula. And the generic version of this formula is just that any nth term, so like here, let's say the 4th term, you can write that, is the first term plus some number d times n minus 1. And I've seen it where the d is in front and where the d is in the back. It doesn't matter. This textbook puts in the back, so matching the textbook. I personally like the d in front. So multiply times the term. All right, so let's look at number 20. Number 20, you're given that a sub 1 equals 6, and you're given that d equals negative 2. And the directions say to find the nth term of the arithmetic sequence, whose initial term, a sub 1, and common difference are given. What is the 51st term? So before we find the 51st term, we're going to find the nth term. We're going to use that formula. So a sub n equals, our a sub 1 is 6, plus, then you have n minus 1, times 2, because for this one it's 2. So a neater version, 6 plus, distribute the 2, 2n minus 2, 6 minus 2, that's 4, plus 2n. Oh shoot, it's negative 2. Dang it. Redo. Alright, so our a sub n is 6 plus n minus 1 times negative 2. There we go. That's what I really meant. So we have 6, distribute the negative 2. We have negative 2n plus 2. 6 plus 2 then is 8. So we have 8 minus 2n. This will give you our nth term. And for this particular problem, it told us to find the 51st term. So that means a sub 51 is what we want. So a sub 51 would equal 8 minus 2, and then our n is 51. So that'd be 8 minus 102, which is negative 94. So if you were to write this whole sequence out, which you could actually do for the rest of your life, because it doesn't end, but if you were to keep writing the sequence out, like starting with a sub 1 being 6, and then going to the next and the next. The 51st term in that sequence would be negative 94, and that's what we were able to just find. All right, let's look at number 26. Okay, number 26, we want to find the 80th term of the sequence negative 1, 1, 3, blah, blah, blah. Okay, so the things aren't directly defined for us like they were in the other problem. So we're going to have to figure some stuff out. We have a sub 1 would be negative 1, because that's what's first. And then we need to know our d. So going from negative 1 to 1, that's adding 2. 1 to 3, that's adding 2. So our d is a positive 2. Now we're ready to write the formula. So a sub n starts with a sub n equals a sub 1 plus n minus 1 times d. So negative 1 plus n minus 1 times our d, which is 2. Distribute the 2. Negative 1 plus 2n minus 2. We get negative 3 plus 2n. Honestly, this and this are the correct answer. This is just more simplified. But that was the answer also. Okay, so we need to find, for this particular problem, we need to find the 80th term. Okay, so we need to find a sub 80. If I plug it in here, you have negative 3 plus 2 times 80. That's negative 3 plus 160. That's 157. So the 80th term of that sequence is 157. It's kind of cool that you can figure that out, I think. All right, next problem is number 32. Now, number 32, you're given some different information. You're given that the fourth term is 3. The 20th term is 35. We need to find a sub 1, d, and the recursive formula, which remember is what we did at the beginning. Defining a sub 1 and then just saying what's happening to it. Okay, so again, we eventually want to use a sub n equals a sub 1 plus n minus 1 times d. But we don't know our a sub 1 and we don't know our d. So we're going to have to figure those out. We know that the fourth term is 3. So that means a sub 4 equals 3. So when n is 4, a sub n is 3. So we could do 3 equals a sub 1 plus n would be 4 minus 1 times d. So 3 equals a sub 1 plus 3d. Now let's look at the other one. We know that a sub 20 equals 35. So when n is 20, 35 equals a sub 1 we don't know, plus this would be 20 minus 1, and then times d. So 35 equals a sub 1 plus 19d. Now both of these have an a sub 1 and both of these have a d. So this actually goes with our systems of equations that we're doing last time. Let me solve each of these for a sub 1. This one will just move the 3d over. So 3 minus 3d equals a sub 1. This one, 35 minus 19d equals a sub 1. So that means the leftover part needs, like, they're both equal to a sub 1. So these other parts have to equal each other. So 3 minus 3d equals 35 minus 19d. I'm going to add the 19d over here. So 3, add that, we get plus 16d equals 35. Subtract the 3, so 16d equals 32. Divide by 16, so that means our d has to be 2. Alright, so now we know our d. We're going to use that to find our a sub 1. Pick a formula of those. It doesn't matter which one. We're just going to use it to find our a sub 1 anyway. I'm going to pick this last one here. That 3 minus 3d equals a sub 1. And I'm going to plug this in for d. So 3 minus 3 times 2 equals a sub 1. 3 minus 6. So negative 3 equals a sub 1. So now remember, we need to come up with the recursive formula. And the recursive formula is where you define your a sub 1 first. And everything is based on the one before it. I am not spelling recursive right. Here we go. Recursive formula. Alright, so our a sub 1 equals negative 3. We just found that. And then each next term is built on the one before. So a sub n would equal the term before it, a sub n minus 1. And then our d, which would be plus 2. That's the recursive formula for this sequence. If you have any questions on any of this when you're going over it, don't hesitate to email. If I don't email you back within a day, email me again. Just in case I read it at the wrong moment and then I forgot to reply. Try not to do that, but it happens. Alright, now let's look at number 34. Number 34, we're given that the 8th term equals 4. We're given that the 18th term is negative 96. Same direction, so we have to find a sub 1. D and the recursive formula. Alright, so again, using the formula for the nth term, the a sub n equals a sub 1 plus n minus 1 times d. Use the first factor we know, which is that the 8th term is 4, so a sub n will be 4. So 4 equals our a sub 1, which you don't know, plus we do know n to be 8. So 8 minus 1 times d. So 4 equals a sub 1 plus 7d. I'm going to be solving for a sub 1. So 4 minus 7d equals a sub 1. We also know the 18th term is negative 96. So negative 96 equals a sub 1 plus, this is the 18th term, so 18 minus 1 times d. So negative 96 equals a sub 1 plus 17d. Subtract it over, you get negative 96 minus 17d equals a sub 1. So since they're both solved for a sub 1, I'm going to use those and find d. So that means 4 minus 7d has to equal negative 96 minus 17d. Add the 17, so that'll be 4 plus 10d equals negative 96. Subtract the 4, we get negative 10d equals negative 100. So d equals negative 10. So I'm going to use that d to find my a sub 1. Yeah, I'll choose that one. 4 minus 7d equals a sub 1. So I'm going to plug that negative 10 in for d. So 4 minus 7 times negative 10 equals a sub 1. So 4 plus 70, which is 74, is our a sub 1. So there's our a sub 1. Here's our d. The only other thing we need to define is the recursive formula. Okay, recursive formula, first of all, a sub 1 is 74. Then our next term, a sub n, we'll get from taking a sub n minus 1 and then subtracting d because our d is negative. So that whole thing is our recursive formula. Alright, now our arithmetic series, which is the sum of an arithmetic sequence. Alright, the sum formula is S sub n equals, you take your number of terms divided by 2, then add your beginning with your end. You don't have to do anything else in the middle. Alright, so number 40, we have to find the sum of, I think I can fit it down here. Okay, we have 2 plus 4 plus 6 plus blah 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 plus 2n. So our a sub n actually has an n in it. So S sub n then equals n over 2 times a sub 1 is 2, a sub n is 2n. We could divide both of those by 2, or just basically multiply times that, so you'd have the 2's would cancel out, you just have n plus 2's would cancel out, and you have n squared. so n plus n squared, or s sub n could equal n times 1 plus n. They're both good answers for the sum of the sequence. All right, let's look at number 44. Number 44, we have the sequence 1, or the series thing, arithmetic, but things being added together. So 1 plus 3 plus 5 plus blah, 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 till we get to 59. Number 44 says to find the sum. So if you think about our formula, remember the formula is S sub n equals n over 2 times a sub 1 plus a sub n. Alright, we have our a sub n. That's 59. We have our a sub 1. It's 1. We don't know n. We don't know how many terms this is. So you actually have to find n first. Alright, and we're going to go back to that arithmetic sequence formula. A sub n equals a sub 1 plus n minus 1 times d. We know our a sub n is 59. Our a sub 1 is 1. N is what we don't know. We do know the difference. To get from one to the next, they're adding 2 every time. So it's a positive 2. Now I'm going to solve this and figure out what n is. So 59 equals 1 plus, distribute the 2, 2n minus 2. 59 equals negative 1 plus 2n. Add the 1, you get 60 to equal 2n. Divide by 2, and you get n to equal 30. Alright, so our first mission is a success. We found n first, and now we need to find the sum. Alright, so our sum comes from that formula there. The S sub n equals n over 2 times a sub 1 plus a sub n. So our n is 30. So we have 30 over 2 times a sub 1 is 1 and a sub n is 59. So you have 15 times 60, and 15 times 60 is 900. That's it, there's no units. Alright, that is it for arithmetic. Arithmetic has the D, which gets you from one to the next. You just add or subtract. Alright, so stay tuned. I'll also have my geometric video and my 12.5 video. Have a great day. Be safe.